it's time for us to start. So good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. My name is Francesco Petruccione, and I'm the interim director of NITheCS. This afternoon, we have the great pleasure of having Professor Emmanuel Adetiba with us. Emmanuel studied information communication engineering at Covenant University in Nigeria, after which he has spent some time as a postdoc at the Durban University of Technology, so that he has a long-standing collaboration with South Africa. And currently, he's a full professor at Covenant University, where he was also the head of the Department of Electrical and Information Engineering, as well as the director of the whole of ICT. Yeah. This year, he's on sabbatical in South Africa. His base camp in South Africa is DUT, where he spent time previously. But this week and next week, he will be with us in Stellenbosch. Yeah? Emmanuel, it's a great pleasure to have you share with us your talk on FEDGEN, a federated general omics cloud computing infrastructure for precision medicine and artificial intelligence research in Africa. Emmanuel, thank you very much for being with us. If you want to share your screen and start your presentation, you are most and welcome. Yeah. Well, with that, I will do the usual recommendation to the online attendees to please pose questions in the Q&A, or at the end of the talk, please raise your hand and we will give you the permission to talk live. Yeah. So, Emmanuel, please, over to you.
Okay, thank you, Professor Francesco, for that beautiful introduction. So I will share my screen right away.
Yeah.
And I will present to this online audience. The topic, as Professor Francesco has also mentioned, is FEDGEN, which is an acronym for Federated General Omics Cloud Computing Infrastructure for Precision Medicine and AI Research in Africa. And this research is being funded by World Bank and the France Development Agency. And of course, the funding is being facilitated by the Association of African Universities as the regional facilitation unit, and the National University Commission in Nigeria as the national facilitation unit. We have partners in West and Central Africa that are working with us on this project. And the introduction, my Professor
Emmanuel, sorry if I interrupt. Would you mind play the full screen?
Okay,
excellent.
So
Thank you very much.
I'm doing that now. Thank you. So I've been introduced, so I won't waste time on that. My name remains Emmanuel Adetiba. Okay, and the FEDGEN aim and objectives. The aim of the Federated General Omics project is to develop groundbreaking research artifacts on federated cloud computing, artificial intelligence in its different shades and forms, and general omics for precision medicine in Africa. And the specific objectives to realize these aims are actually to address some critical issues in the continent with respect to research capacity, as well as research infrastructure, early disease diagnosis, public health education, and large omics data analysis, and as well as modeling of diseases using large-scale data sets. And to also mention that the center where this project is primarily domiciled is the Covenant Applied Informatics and Communication Africa Center of Excellence, which is at Covenant University. And of course, we have our collaborating partners working with us on the project. At CAPIC-IS, that's the acronym for Covenant Applied Informatics and Communication Africa Center of Excellence. We have three major projects. FEDGEN is one of the projects. We have the malaria project, and we have a group that is working on the malaria project. We also have the cancer project. Our cancer project has to do with breast and prostate cancer, and we are also doing a bit of things on the lung cancer. So that is, and setting the background, Omics, big data. Stephen and his colleagues, they made a projection up to 2025 by comparing genomics. Of course, genomics is a variant of omics with astronomy and YouTube and Twitter data set. And they were able to show that genomics is the most demanding of these domains, talking about astronomy. Of course, before now, when you talk of astronomical data, that gives an impression of a very big data. But genomics is also really matching and even beating astronomy when it comes to big data. And this is posing a lot of challenge in respect of data acquisition, storage, distribution, and analysis. And of course, Stephen and the colleagues made a clarion call for community-wide planning for the omics challenge of the next decade to realize precision medicine. A lot of efforts are already ongoing in the West in the advanced climb with respect to the use of big omics data set for precision medicine. And it is also good for Africa not to sit back. It's also good for Africans to contribute in order to address diseases that are really specific to the African space. So that is a background with respect to omics as a big data problem. Then talking about artificial intelligence, Vladimir Putin, the Russian president, posited not too long ago that any country or whoever leads in artificial intelligence in 2030 will rule the world until 2100. So artificial intelligence is a critical technology in this decade. And one of the leading scientists at Stanford University also posited that artificial intelligence is a general purpose technology, GPT, like electricity. Of course, we know how useful electricity is when it comes to life. And that is exactly what artificial intelligence is actually becoming. And when it comes to capacity and implementation and research on artificial intelligence, I have this figure on the right to illustrate. You can see the very big black circle. That circle represents those that are talking about AI. You can see that there's a lot of hype. A lot of persons are talking about AI, and the hype is everywhere. Meanwhile, if you see the green tiny circle, it's talking about those that are really implementing AI. If you look at the yellow circle, it's talking about those that are doing research on AI. And the tiny red circle that is almost invisible is talking about those that are actually building AI products. So this is to show us that there's a lot of questions that researchers, not just in the advanced climb, but even in Africa, should actually pay attention to when it comes to AI. It has achieved a lot of breakthroughs, and we can also leverage on this to achieve precision medicine. Then federated cloud. Of course, the fundamental idea of cloud computing is to deliver computational resources as a service over the internet, of such that you don't need to own your own computational resources before you can make use of very huge computational facilities, either for storage or for analysis. And federated cloud is actually a paradigm that provides a cost-effective alternative for building high-performance computing infrastructure. We know that in the advanced climb, you talk of supercomputers that contain millions of cores of processing units. But due to paucity of funding within the maybe sub-Saharan African, only a very huge supercomputers may not be achievable within the short term. But a way around it is to set up a federated cloud, which is a combination of small, medium, standalone cloud or high-performance computing facilities, and aggregate it into larger facility for storage of data, for processing of data. And in order to realize precision medicine, apparently there will be need to have very large omic data set. The omic data set comprises of genomics. It can also have proteomics. It can have metabolomics. It can have radiomics. Radiomics has to do with imaging data sets. It can also have breadth omics and different types of omics. When you have such a data set available, it's easy to realize precision medicine. And of course, when you have huge data set, traditional modeling approaches may not be able to deliver a very good result. And that is why artificial intelligence becomes handy. And to run artificial intelligence that contains billions of parameters, just like we have for the series of GPTs, the GPT-3, 3.5, and GPT-4, that contains billions of parameters. This can only be done on high-performance computing platform. And examples of such platform are federated cloud, supercomputers, quantum computers. And currently, a lot of effort is also being made to have high-performance computing on edge devices. And the architecture of a federated cloud is what we have in this figure. You have the cloud users. In this context, we are talking of researchers that want to carry out research computing. And we have different private cloud providers that are located at different locations. And you have the component that handles brokerage with respect to each of the different cloud providers. And of course, in order for the client or the researcher that want to make use of the computational resources to have the quantity and the quality that is required for whatever task needs to be carried out, a federated cloud broker can pull resources from different cloud service providers. And the pooling of the resources is blind to the end user. And of course, the cloud service providers, they are also able to take advantage of situation where the client or the cloud computing user requires resources that are beyond what they have available. They can just burst into other cloud providers and the end user is satisfied. The service level agreement is met and the providers are happy. The researcher or the end user of such cloud platform is also happy. Okay, so the FEDGEN, currently we have infrastructures that are being developed in order to carry out the different researches and training that are taking place within our Center of Excellence and with our collaborators. We have the FEDGEN testbed is one of the infrastructures that we have in place. We are also building the FEDGEN data center, and we are also building edge computing testbed. A brief description of the FEDGEN testbed. It is an experimentation platform for federated cloud computing because we have engineering students and engineering researchers that are also coming up with novel algorithms and models in order to realize the goal of federated cloud computing. And we have bioinformaticians that are making use of artificial intelligence and also omics data set for their respective research within the West and Central Africa region. And the partner universities in Nigeria, we have 3 universities that are working together in Nigeria. Covenant University is taking the lead. We have Afe Babalola University, and we also have our sister university, which is Landmark University, participating in this effort. We have a university at Democratic Republic of Congo, that is ULPGL, and also at Senegal, the Gaston Berger University. At Senegal, we are working together, and currently we are also exploring the possibility of having test bed, that's high performance computing platform at the Durban University of Technology, this skill collab, and we are exploring possibility of also having high performance computing facility at NITheCS. I know they have access to the CHPC in South Africa, but there's nothing stopping us from having maybe GPU cluster at NITheCS that even has quantum computing capability. And we are able to interconnect all this together. And the data that originate from Africa do not need to go outside Africa for storage and for analysis. So those are things we are looking at. And a typical testbed platform comprises of the compute. A region can have up to 6 compute nodes. The networking device, which is the switch, is there, which provides interconnection among the different compute resources, and also connection by external users. We have different software, the Meta as a service controller that control the interconnection of the different compute nodes, and we have Juju controller. We have for our test bed and even for the data center, we are making use of Ubuntu Linux as our base operating system, and we are making use of OpenStack cloud operating system in order to power and run the testbed region. So a typical FEDGEN testbed region comprises of these different infrastructure, and we could have this in all our collaborating centers. And this is the setup of FEDGEN testbed at Covenant University. You can see the students. Some of the students are from Tanzania, some are from Democratic Republic of Congo, some are from Nigeria. We have the management of Covenant University paying a visit to that testbed laboratory at Covenant University. So currently we have 4 regions for the testbed at Covenant, but by the time we complete the federation that we are working on, one of the regions will be sited at Democratic Republic of Congo. The other region will be sited at Lamarck University. We are also working on procuring a region for Afe Babalola, and we are interconnecting all of this together. So researchers, no matter where they could be within the collaborating university, can have access to the pool of computational resources that are available on this platform. And procuring these facilities, we have been funded by World Bank to procure these facilities. And of course, we've also gotten funding from France Development Agency to get this done. And currently we have the Jupyter Notebook on the FEDGEN testbed platform. This is just a dashboard. The Jupyter Notebook is an integrated development environment that allows research programmers or scientists to carry out programming using Python within the environment. This is currently available. It's accessible on the internet. The URL is jupytermb.fedgen.net, and we have users that are already on that platform. And this is just an interface that shows programming being carried out on that platform. So wherever the research programmer is or the researcher is in any part of the world, they can have access to this platform. And many more software resources are coming up. Okay, that's about the FEDGEN testbed. Now the data center. Currently, we are at an advanced stage in setting up the data center. We have, this is the figure is showing the laboratory at Covenant University, where we have the client computers, and we also have the data center with the rack. Some of the systems we have in the data center, we have some front-end servers that contains up to 24 CPU cores. We have a storage server that has up to 16 CPU cores, 1 terabyte of RAM, and it has like 30.72 terabyte of hard disk. We have a GPU server already set up, and we are in the process of also putting Jupyter Hub on that GPU. That GPU is a NVIDIA A100 40 gigabyte card, and this provides opportunity for high performance computing. We also have other backend servers that is of 120 CPU cores, and we have like 1.536 terabyte. On the GPU server, we having memory capacity 64 gigabyte memory on the GPU server, and we have the networking device. So our vision is, we started this project in 2019. So we target a space of 10 years. By 2029, our vision is to have the data center listed in the top 500. Top 500 is a platform that showcases the supercomputers in the world. And of course, for any researcher that wants to, we are making provision for researchers within the African region to request computational resources on that platform. And in order to do that, we have this dashboard, which is fedgen.net/FEDGEN clouds. the form to make requests is available on that platform, and the different facilities we have are also available. Okay, that's on the infrastructure for training and for research that we have at CAPIC ACE in respect of the FEDGEN project, and the ongoing research and development projects that are connected with FEDGEN. We have the SEC FEDGEN architecture project that is being funded by AFD, and in respect of that project, we have been able to come up with different models and algorithms that have been tested, and some of them are already published. And currently, we are working on turning them to apps, cloud-native applications that we can test within the FEDerated cloud platform. For instance, we have the FEDAGOS, is a federated architecture for monitoring of cloud within a federated platform. Then we have the secured federated intrusion detection model, which we developed using deep learning and blockchain. We also have the federated secured malware detection model, which we developed using federated learning paradigm. We are also working, we are at the beginning stage of developing a federated load balancing algorithm. And the target is, once all these algorithms are developed, they are tested on the test bed, then we can scale them to the data center. And because we are getting funding to do all this, we also make the softwares available so that other researchers can also extend what we have been able to do. Beyond the SEC FEDGEN project, we have the FEDGEN Public Health Information System and Data Hub. And this is a platform where our researchers are able to put up a kind of a blog on malaria that the public can easily relate with, on cancer, breast, prostate, and lung cancer. And this platform is already up and running. We're also working on setting up an application, a cloud-native application, where the researchers can store their data and analyze their data. We are currently developing that platform. And one of the projects we are also evolving is the application of generative AI for text-to-speech, such that the information we have on the public health information system could be accessible in African languages. We are starting with Yoruba, which is a local language in Nigeria, and we are hoping to capture more African languages. And this kind of model could be adopted even in telecommunications, in fintech, and in so many other areas. Another project that we have been able to prototype is early detection of lung cancer using Hedge AI and Britomics. Britomics is breath analysis. So instead of having to go invasive in order to screen for lung cancer, we are exploiting volatile organic compounds in breath to profile the existence or non-existence of lung cancer from individuals. Those are some of the ongoing research and development projects that are on the FEDGEN. This is the dashboard for the FEDGEN PHIS. The URL is fedgen.net/PHIS, and we have the architecture for the data hub. Currently, the architecture is being properly designed, and the implementation is going to follow. Now, this is one of the outputs we have gotten in respect of the SEC FEDGEN project. We have done a first round of revision for this work. IEEE Access is currently attending to the revised version. The title is a secure federated intrusion detection model with blockchain and deep bidirectional long short-term memory network. And there are other publications we've been able to, in the Scopus Index, the outlet that we've been able to do with respect to the FEDGEN project. We have the FEDGEN testbed, of course, published in a conference proceeding already. We have the FEDAGOS, which is a monitoring architecture for federated cloud computing infrastructure. This is already published in IEEE Access. We also have monitoring and resource management taxonomy, which is a survey paper where we try to explore the different taxonomy for interconnection of clouds or federation of cloud. And these are other publications we have been able to come up with in respect of the FEDGEN project. And this is a setup during the development of the electronic nose device using Hedge AI and Britomics, that's breath analysis, for early detection and profiling of lung cancer. And now, with respect to capacity development, which is one of the core objectives of this project, we have quite a number of postgraduate trainees, short courses, and internships that we have done and that are still ongoing. We have been able to produce 10 master students in information and communication engineering, 1 master student in computer science. They've completed their program at Covenant University. And currently, we have 2 master students in information and communication engineering and 7 master students in computer science that are on their master's program. And all of them are working on the FEDGEN project. Meanwhile, our sister groups at the Center of Excellence, the malaria group, they have students that are also doing research in biochemistry, microbiology, and we also have students that are doing research in bioinformatics. The number here is just for students that are working on the FEDGEN project. And of course, we also have 4 PhDs in information and communication engineering that are ongoing, 2 PhDs in computer science. 1 PhD is also ongoing at the Gaston Berger University in Senegal. And we've been able to do boot camps, FEDGEN boot camps. 2 have been done so far. This boot camp provides an opportunity for the collaborators to come together and brainstorm on the different aspects of the project. And we have also done high-performance computing workshop, which is where we train professionals and postgraduate students on high-performance computing with respect to programming, with respect to administration, with respect to configuration. And we've trained more than 100 trainees with the high-performance computing workshops. We've also awarded interns that worked with us on this project. And our target with respect to capacity building, we are hoping to have further collaboration with the KZN ISKI Collab, as well as the NITheCS at Stellenbosch University to do further short courses. Could be in the area of quantum computing, generative AI, high-performance computing, cloud computing, and in other areas. And this is a snapshot of the FEDGEN bootcamp that we've done in the past. And this is another snapshot of the high-performance computing workshop, the second high-performance computing workshop specifically. And we have the workshop. For the high-performance computing workshop, we attracted facilitators from France, that is Ethos in France, and we also have other facilitators that are drawn from Senegal, and the trainings are archived on our YouTube channel. The URL to that channel is indicated on this slide. So our next steps with respect to FEDGEN research and collaboration, hoping to extend this work to the Southern Africa region. So currently we are working on joint grant proposals with NITheCS at Stellenbosch University in South Africa. We are also working with KZN ISKI Collab on grant proposal writing. We are also exploring joint supervision and exchange of postgraduate students, as well as writing and publishing of high-impact manuscripts and collaborations with respect to trainees, short-term trainings on cloud and high-performance computing, artificial intelligence, big omics, data analytics, and etc. So the project team and partners at Covenant University, the center leader, we have Professor Emeka Iweala, and my humble self as the deputy center leader and the principal investigator for FEDGEN. We have co-investigators in the area of ICE, we have co-investigators in health, we have system engineers, we have software engineers that are part of the team at Covenant, and our collaborators in South Africa, we have Professor Surendra Thakur, who is the director of the KZN ISKI's Collab at DUT. We have Professor Moyo, who is the DVC Research, Innovation and Engagement at Stellenbosch. We are also exploring collaboration with Professor Francesco, who is the host of this colloquium. And we have Suresh Maslamoni, who is a system administrator under the H3A Bionet project at the University of Cape Town. These are persons that are, and our West and Central Africa and international collaborators, we have Professor Ezekiel Adebiyi, who is a co-principal investigator on the FEDGEN project and is at the German Cancer Research Center. We have Professor Satafe Babalola at Landmark University, at DRC Congo, at Gaston Berger University. And we also have industry support. IBM has provided support with respect to cloud computing trainees. And also HP Enterprise has also provided support. We have clinical collaborators as well, ACE Medicare in Nigeria. We have Lagos State University Teaching Hospital, and our other international collaborators. We have Ethos, we have Henria in France, and also IRD. Okay, so just to conclude this talk, the FEDGEN research project is a bold step to develop homegrown, I mean African-based effort and also capacity building with respect to cloud, federated cloud infrastructure and high-performance computing, so that we can achieve precision medicine and we are able to also provide solution to our local problem, get our data locally and store them in our home private local infrastructure and also analyze them on our own local infrastructure. So we appreciate all partners and collaborators and funding agencies for all the support that they have given us in respect of this project. And I want to say thank you, merci beaucoup, siyabonga to all for listening to this presentation. Thank you, everyone. Okay.
Thank you very much, Emmanuel, for a very nice talk and for sharing these very ambitious projects of your university and put them in a broader African context. Thank you very much. Very, very impressive. I want to renew the offer to the participants to raise their hands and so that we can give them the right to ask you question directly. And maybe while they think about it, there is a question in the Q&A by Peter van Heusden, and he asked, HPC and cloud management skills are very rare in Africa. Have you developed a curriculum to train the people who will run the cloud?
Okay, so let me respond to that. The postgraduate trainees that we are doing in information and communication engineering, as well as computer science, and the other programs that are connected with malaria and cancer research, that's biochemistry, microbiology, we were mandated by World Bank to revise our curriculum so that it can reflect some of these cutting-edge technology that we are working on. So yes, we have a revised curriculum. And one good advantage of short-term training is the fact that within 40 hours, maybe spanning a period of 2 weeks, you can pick a cutting-edge technology and invite experts to actually teach professionals and also postgraduate students on this cutting-edge technology. That is why we are doing the high-performance computing workshops. So we've been able to, we are really able to attend to that. I hope I've answered that question.
Yeah, thank you very much, Emmanuel. And close to that question, do you have linkages to our South African Center for High Performance Computing? Because they're also very active in training and developing HPC tools for all of us.
Yeah, exactly. We are exploring a collaboration with the Center for High Performance Computing. And one part of our plan is to visit that center for a period of 2 weeks. Myself and my team members, we are working on a visit to the Cloud and High Performance Center for High Performance Computing at Pretoria, and I think the one at Cape Town also. We are
Yes. And you know, Emmanuel, NITheCS has a very good working relationship with the CHPC. So if we can be of any assistance in establishing the link, just let me know. Yeah, that would be a pleasure. Yeah, and it's not far away from here, just a 30 minutes drive. Yeah, or 40 minutes drive. Yeah, it's very close. Yeah.
Wow, I see. Okay.
Emmanuel, there is another question in the chat by Bushle Nitzwa. Thank you, Emmanuel, for the nice presentation. How can one get the intention post? Also, how can one get more information on potential PhD studies and internships?
Okay, good one. In respect of the PhD studies, our website normally advertise when we are recruiting PhD and master students. So I'm going to send the link to the website on the chat. The website is covenantuniversity.edu.ng. So,
we can see it on your last slide, Emmanuel.
Exactly. It's actually on the, apparently, it's on the slide anyway. So information on the PhD and also the master's program are usually posted on that platform. And then in respect of internship, we normally get funding on annual basis up till 2024 from France Development Agency. So once that opportunity is available, we also share it within the network, and we try to also share it with NITheCS so that it can be showcased for persons that are interested. That's in respect of internship.
Excellent. Thank you very much. Are there further questions or comments for Emmanuel? I don't see at the moment any raised hands, and there are no more entries in the Q&A in the chat. Here, John Hargrove raised his hand. John, just a second. Here, now you're allowed to ask your question, John. Please, just unmute yourself.
Hi. Do you hear me?
Yes, we can hear you clearly.
Okay.
We can hear you.
Very nice talk. Just one thing which you may have pointed out, but I didn't pick up on it. So, hopefully you'll get deposited on your cloud very large amounts of data. What is the real long-term security of those data? Suppose I put data on that cloud. In 100 years' time, how is that data sort of kept secure and available, for forever, as it were? Is that in your gift, or do you look at a shorter time frame?
Thank you. That's a very good question. Long-term plan in respect of data storage up to 100 years. Wow, very good question. Currently, we are considering the short term, but I can assure you that we'll pay attention to this long-term data storage. But it's actually all about availability of resources, computational and storage resources. So the more resources we have, the more we are able to perpetuate the data storage. And we are paying a lot of attention to security paradigms. We're doing active research on cybersecurity using blockchain. We are also working using homomorphic encryption to ensure that data that are stored on the platform are also not vulnerable to attacks. So that is part of our major short-term consideration.
Yeah. Can you still hear me?
Yes, we can still hear you. If you have follow-up questions,
just to carry on, this was not meant as any way critical of you, but it is a general problem. When I think back, I was at Pembroke College in Oxford, and they managed recently to get a new library, and were able to get old stuff in their archives, and they had data there which was 600 years old. And you just think to yourself, that's what they managed to do 600 years ago. And are we going to be able to do the same thing for people 600 years down the line who might still want to look at our data? And it seems to me to be actually a very serious problem. And particularly as we get more and more, absolutely massive amounts of data, how can we actually make sure that it is actually going to be available in perpetuity? I certainly don't expect you to answer that question, but just to put it out there as a comment. But thank you very much for your talk.
Okay, thank you, John, for that wonderful comment.
Thank you. And there is another comment in the chat by Damola Akinola, and he asks whether you will be happy to share the slides. and Emmanuel, if you email them to me, we can post them on the NITheCS website next to the link to the video recording of your talk.
Apparently, I'll do that right after this colloquium.
Perfect. Thank you very much. And the YouTube version of the talk should be available by, let's say, by tomorrow sometime. Yep.
Oh, beautiful, beautiful, beautiful.
Excellent. Then I don't see any further questions or comments or raised hands for that matter. So, Emmanuel, then it's my pleasant duty to thank you very much for your time. And